Good evening, students. Welcome to Unacademy, the largest online e-learning platform. And today we'll be discussing the lecture 2 on circuit theory crash course. I've started the circuit theory crash course yesterday, and yesterday we have seen some basic elements. And today we'll be discussing about Kirchhoff laws and the different types of sources. Mulkala Koteshwar, thank you. Before that, let me tell you I am Y Shravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and cracked GATE. I request you guys to share this to most of your friends. फटाफट से शेयर कर देना, लाइक करना और सब्सक्राइब भी कर लेना. Let me explain you the Unacademy Learning app installation. In Play Store, type Unacademy Learning app and you'll get this installation. Click on this install. And if you are opting for GATE and engineering services, you can click on this and click on this plus subscription in step 4, and you should click on this get subscription. And you have both plus and iconic subscriptions, wherein you'll get a dedicated mentor for your iconic subscriptions, and you can use my code as YSK10 to get a maximum discount of 10%. And when you click on this proceed to pay, you'll have payment platforms like debit card, credit card, EMIs, UPIs, wallets, net banking. So using all these payment, any of these payment options, you can make this payment and get subscription to Unacademy. So today's topics are, we'll discuss what are the different types of sources and Kirchhoff laws, Kirchhoff voltage law and Kirchhoff's current law. Sneha, good evening Sneha. Welcome to circuit theory crash course. So I've been telling you, some students were asking me about the clarity of the screen. I request you guys to click on the 3 dots on your screen of YouTube. You'll have 3 dots. If you click on that, you'll have a pop-up wherein you can find quality. Good evening sir, this is Kundan. Good evening Kundan. Nikhil Chakravarti. Good evening Nikhil Chakravarti. Welcome to circuit theory crash course. So we are discussing today's topics, sources, Kirchhoff laws as a part of circuit theory crash course. So let me tell you the classification of sources. So before this, I'll give you the elements were classified as active elements and passive elements. So active elements were those elements which were capable of delivering energy, and they are nothing but the current and voltage sources as we have seen. And passive elements were the elements which are not capable of delivering energy but are capable of absorbing or storing the energy, like an inductor, resistor or capacitor. And now we'll discuss the classification of sources. You can classify sources as the first classification would be independent sources and the dependent sources. Independent source and dependent source. Independent sources can further be classified as voltage source and current source. And this can further be classified as ideal and practical. Ideal voltage source and practical voltage source. And current source can also be further classified as ideal current source and practical current source. We'll look after this one by one. Ramchandra Kumar, good evening sir. Good evening Ramchandra Kumar. Ajay Kumar, good evening. And coming to dependent sources, you have four types of dependent sources. They are vo- voltage dependent voltage source, voltage dependent current source, current dependent voltage source, current dependent current source. Now these two can be classified as voltage sources and these two can be classified as current sources. So this is the classification of sources. So independent source and dependent source, and independent sources are further classified as voltage source and current source, and these can further be classified as ideal and practical sources, and these are classified as voltage dependent voltage or voltage controlled voltage source, you can call it as, or you can also call it as voltage controlled current source, current controlled voltage source, and current controlled current source. So these are the classification of sources. Now coming to what are independent source and what are dependent sources. Independent sources will establish a voltage or a current in a circuit without relying on the voltage or current elsewhere in the circuit is an independent source. So what is an independent source? Which establishes a voltage or current in a circuit without relying on voltage or current elsewhere in the circuit is called as a independent source. And what are dependent sources? Dependent sources will establish a voltage or a current in the circuit whose value depends on the voltage or current elsewhere in the circuit. What is the major difference between these two that you observe? Here it is not relying on any value of voltage and current, but here it will rely on the voltage and current elsewhere in the circuit. And we'll see the circle to represent an independent source and a diamond shape to represent the dependent source. This is a major difference that you need to understand. So this is an independent source, this is a dependent source. Hope you are clear with this. Let me tell you once again. So what are independent sources? Independent voltage source or a current source will establish the voltage or current without relying on voltage or current elsewhere in the circuit, whereas a dependent source will establish a voltage or current in the circuit whose value will depend on voltage or current elsewhere in the circuit. And a independent source is generally represented by a circle and a dependent source is represented by a diamond shape. Hope this point is clear for you. Now, so this was the classification and we have discussed what is an independent source and what is a dependent source. Now let us discuss what is a voltage, ideal voltage and practical voltage source, and ideal current and practical current source values. Now if you look at this, ideal and practical voltage source. This is what we are discussing now. So these are about independent sources. These are independent. We are discussing about independent sources. In that we are discussing what is ideal and practical dependent source. Ideal and practical dependent voltage source. We can also call them as ideal constant voltage source and ideal constant current source, or a practical constant voltage source and a practical constant current source if it is a DC source. Now, what is that ideal? What is that ideal voltage independent voltage source is? What is that ideal independent voltage source? Ideal voltage source or ideal independent voltage source. The energy source, the energy source which gives constant voltage across its terminals, Hope you are able to understand. The energy source which gives constant voltage across its terminals irrespective of the current drawn is called as a ideal constant voltage source or ideal voltage source. Now what is it is, I'll also explain you the diagram. Now if you observe this, if we consider this is voltage and this as current, if irrespective of this value of current, if the voltage is constant, if the output voltage is constant, this is called as an ideal voltage source, and it is represented by a circle with this. This is the voltage and the output voltage is also V. Pavan, hi sir, hi Pavan. Karthik, good evening sir, good evening Karthik, good evening Pavan. Welcome to Circuit Theory Crash Course. We are discussing the different types of sources and KVL and KCL today. Shivakumar, good evening sir, good evening Shivakumar. So this is ideal voltage source. Irrespective of the current drawn, the voltage is across its terminals is constant. Now as you can see, this is the voltage source. Irrespective of any current, this line represents, this dotted line represents the ideal one, ideal voltage source. Now but practically, now what is practical voltage source? A practical voltage source, if you consider a practical voltage source, this will not give you, this source does not give you any constant voltage. Instead, you can observe a drop in the voltage. You'll observe a drop in the voltage, and this was the ideal one. Now if you consider this as the ideal and this as the practical one, where this is voltage and this is the current. Raviteja, good evening sir, good evening Raviteja. Kingston, hi sir, hi Roger Kingston. So this is a practical, this is due to the presence of the internal resistance, which is considered to be Rs, and here the voltage will be, if this current is Is and this is Vs, output voltage is equal to Vs minus Is into Rs. Here the voltage is not constant, and for ideal constant voltage source, you can say resistance value is 0. If this value is 0, V is equal to Vs, which is same as this case. If this is Vs and this is V, so the value of V will be equal to Vs. So this is practical voltage source. Now let us look at ideal and practical independent current source. So if you observe this, what is ideal current source? As we have seen earlier, the energy source which gives constant voltage across its terminal irrespective of the current drawn is a Indrakanti Navin Kumar. Good evening sir. Good evening Navin. Welcome to Circuit Theory Crash Course. So this is also a source that gives constant current irrespective of voltage, is a ideal constant current source. Now if you can observe this current source, as we know, it is represented by this, and if you observe this, the current across this load terminals, if you see, is equal to this current Is. So I is equal to Is. This is an ideal current source. Whereas coming to a practical current source, this does not have if you look at the VI characteristics, as you know, if you look at the VI characteristics, if this is I and this is V, the value of current will be constant irrespective of the voltage. That is, this is ideal. This is an ideal case. Whereas practically you will observe a drop in the current. This is because of a current source will always have an internal resistance of value Rs parallel to it, and therefore this current that you get is, if you say this is I1 and this is Es, so the value of current I is equal to Is minus I1, which is this difference. You will not have the same value, which is also V by Rs. You can write it as Is minus, if I1 is this voltage is V or Vs, you can write it as Is minus Vs by Rs. Now for a practical current source to be an ideal current source, for an ideal current source, the value of Rs must be infinite. Now let me tell you why the Ashwita. Good evening Ashwita, welcome to Circuit Theory Crash Course. Now we have considered the value of Rs for an ideal voltage source is 0 and the value of ideal current source Rs value is infinity. Let me tell you, because for a voltage source the resistance is in series and for a current source the resistance was in parallel. And why do this Rs is equal to 0 and why is Rs is equal to infinity? If this is the voltage, this is the current. Now if the value of resistance is 0, the voltage drop across this resistance is also 0. Mulkala Koteshwar, nice sir. Thank you Koteshwar. If this value is 0, the total voltage that is given here will appear across this. If this value keeps on increasing, the voltage value keeps on decreasing. Because V output voltage, if this is Vs and this is Is, V is equal to Vs minus Is into Rs. As you increase Rs value, Vs minus Rs value starts decreasing. Therefore, for an ideal case, the value of internal resistance must be 0, or you can say internal resistance of ideal voltage source. This is sometimes given in competitive exams as an MCQ. Internal resistance of an ideal voltage source is always a 0 value for an internal resistance of a ideal voltage source. Jahnavi, nice explanation sir. Thank you Jahnavi. And similarly, if you observe for this, if there is some current that is flowing, if you consider this as Is, and whenever you have a resistance here, if it is equal to 0, let us say, it will be a short circuit and the total current will flow instead of flowing it to the load. If you have a current source and if this is a short circuit, R is equal to 0 indicates there is no opposition. Whenever there is no opposition, total current will try to flow through this part. That should not happen. We should get this current to the load. That is the reason if you have the resistance is equal to infinite, if the resistance value is equal to infinite, there is a huge amount of opposition and this will become an open circuit, and the total current that is flowing through this will try to flow to the load. That is the reason for an ideal current source, resistance must be infinite. For an ideal voltage source, the resistance value must be 0. For an ideal current source, the internal resistance value must be, for an ideal current source, internal resistance is infinite. Raviteja, sir, what is the live class timing? The live class timing is from 6:45 to 7:45 every day PM. So you can join me on live classes from 6:45. I hope you got the difference between these two. Let me conclude this point. What is the conclusion that we got from this? That is, one is internal resistance of ideal voltage source is dash, and the internal resistance of an ideal current source is dash. Now I want you guys to tell me what is the internal resistance of an ideal constant voltage source and what is the internal resistance of a ideal constant current source. Rajkumar, Sai Pavan, good evening. Raviteja, Janavi, Koteshwar, Naveen, Shiva, Pavan, Ajay, Ramchandra, Nikhil, Sneha. I just want one of you to answer this question. What is the internal resistance of a ideal voltage source? Jahnavi, it is 0. The internal resistance of an ideal voltage source is 0. And the internal resistance of an ideal current source, infinity. That's exactly correct. Correct. Jahnavi, very good. So you are following the class. Internal resistance of an ideal voltage source is 0. And the internal resistance of an ideal current source is infinity. So till now we have discussed, let me tell you, yeah, this is what we have discussed. We have discussed independent sources, ideal and practical voltage source, and ideal and practical current source. Yeah, Kundan, very good. It is 0 and infinity. Very good. That's a good answer. Now we'll discuss dependent sources. Now we shall discuss the next topic, dependent sources. So hope you are clear till this point. Now let me tell you about the dependent sources. Dependent sources. Now let us look at the dependent source definition that we have seen already. Now what are dependent sources? Dependent sources, let me take this. So what are dependent sources? Dependent source will establish a voltage or current in the circuit whose value depends on the value of voltage or current elsewhere in the circuit. So the value of this voltage and current source will depend on, what are dependent sources? Sources whose voltage or current value will depend on voltage or current value elsewhere in the circuit. So this is the dependent source definition. Yeah, that was good answer, Kundan. I'm sorry. So these are the dependent. So this is the definition of a dependent source. Now let me tell you what are the different types of dependent sources one by one. You can classify them as two parts. One is the voltage source. The other one is as the current source. So the classification can be made like this. So one can be voltage controlled voltage source and current controlled voltage source. And in this you can have voltage controlled current source and current controlled current source. So these are the two classifications of voltage and current source. So I'll write voltage controlled, I'll write it full once. Voltage source, current controlled voltage source, voltage controlled current source and current controlled current source. Now let us write this. It is voltage controlled voltage source. This is current controlled voltage source. Kiran, thank you Kiran. Good evening. Welcome to Circuit Theory Crash Course. And this is voltage controlled current source, and this one would be current controlled current source. So these are the four types of sources. These two are the voltage sources, whereas these two are the current sources. Oh, and this word controlled can also be replaced as it is dependent. In all these, you can replace the controlled as dependent. Voltage dependent voltage source, current dependent voltage source. In some textbooks, you will find it as, instead of controlled, you can name it as dependent. Dependent. Yeah, so you can name it as dependent. Voltage dependent current source, current dependent to current source. So these are the four types of the dependent sources. Now let me explain you these one by one. So let us consider the dependent sources again. As you know, the dependent sources are represented by a diamond shaped symbol. I'll just make, because we have four, we'll make it four parts here. I'll take four of this and I'll tell you what are these. Now let me tell you, sir, what are the standard textbooks we need to follow for electrical circuits? Yeah, I'll tell you the standard textbooks that you can follow. One is Van Valkenburg. That's one of the very good textbooks that you can follow for circuits, electric circuits. Now, the dependent sources are represented by a diamond shaped symbol. So whenever you come across a shape of diamond like this, you should be in a position to understand that it is a dependent source. So first we have considered these as the two voltage sources when you have plus and minus like this, and these two as the current sources. And what is voltage controlled voltage source and current controlled voltage source is, the value of this voltage will depend upon, let us say, for V1. V1 is the voltage at some other point in a given circuit. So this is a voltage controlled voltage source or voltage dependent voltage source. Similarly, the voltage, or if the voltage of a dependent source is dependent on, in some textbooks you can, instead of taking 4, you will sometimes take it as x v1, and instead of taking 5 you'll write it as k or x or k I2. So this is the value of this voltage is depending on current. So this is a voltage source first, and it is depending on the value of current, and this current may be a current in a given circuit at some other element in the given circuit. So this is a current controlled voltage source. Current controlled voltage source. Now if the value of this current is depending on, if this value of current is depending on, let us say k V3. So this value of current is depending on what? It is depending on voltage. So is this a current source or a voltage source? It is a current source. So it is a current source. And this value of current is depending on voltage. And so the current is being controlled by voltage. So it is a voltage controlled current source. Similarly, if the value of this current, if this value of current is depending on some value of current at some other element, across some other element, then this is a current source whose value is depending on a current. So it is a current controlled current source. Current controlled current source. So once again, without looking at this, we should be in a position to write what are these. Now if you look at one by one, so the first thing that you need to observe from a dependent source is whether it is a voltage source or a current source. Whether it is a voltage source or a current source. Whether it's a voltage source or a current source. Whether it's a voltage source or current source. This is what first we'll identify. First I'll tell you, is it a voltage source or a current source? Is it a voltage source or a current source? It is a voltage source. This is not a current source. Similarly, if you observe this, this is a voltage source and it is not a current source. And if you observe this, this is an arrow mark which represents a current source. And this is also an arrow mark which represents a current source. So finally, this is a voltage source. This is also a voltage source. This is a current source and this is a current source. Now we need to write this value of voltage is depending on voltage. So it is a, I'll erase all this and write directly. The first point that you need to observe is whether the given one is a voltage source or a current source. So this voltage source is being controlled by voltage. So can I write voltage controlled voltage source or voltage dependent voltage source? First one. And now if you look at the second one, this is a voltage source which is being controlled by current. So it is a current controlled voltage source or current dependent voltage source. Similarly, if you observe this, it is a voltage dependent current source or it is a current source which is dependent on voltage. So it is a voltage controlled current source or voltage dependent current source. Similarly, if you observe this, it is a current source. First one, red color here represents, and this is a current dependent. So it is a current controlled current source or current dependent current source. Now let us define this. What is a voltage controlled voltage source? A voltage source whose value is relying on a voltage at elsewhere in the circuit is a voltage controlled voltage source. Let me repeat it once again for you. What is a voltage controlled voltage source or a voltage dependent voltage source? A voltage source whose value is dependent on some other value of voltage in the given circuit, or a value of voltage which controls the voltage source. Similarly, if you observe this voltage source which is current dependent, a voltage source whose value is dependent on the current of elsewhere in the circuit is said to be a current controlled voltage source or current dependent voltage source. Umesh, hi Umesh, good evening. Welcome to Circuit Theory Crash Course. Now what is a voltage controlled current source? A current source whose value is dependent on the voltage at across an element in the given circuit elsewhere in the circuit is called as a voltage dependent current source. Similarly, if you observe this, A current source whose value is dependent on current elsewhere in the circuit is said to be a current dependent current source. Right? Hope you are clear with these dependent sources. Yeah, I'll also tell you the one more definition of this. Nagesh, good evening, sir. Good evening, Nagesh. We are discussing circuit theory crash course. Welcome to circuit theory crash course. Now, let me also tell you what is a voltage dependent voltage source is a voltage source which produces a voltage which is a function of a voltage is said to be a voltage dependent voltage source. A voltage source which produces a voltage which is dependent on the voltage elsewhere in the circuit is said to be a voltage dependent voltage source. And what is this current dependent voltage source? A source whose voltage is a function of current elsewhere in the circuit is called as a current dependent voltage source. Nice teaching, sir. I'm watching your videos. Awesome teaching. Thank you, Nagesh. And what is current voltage controlled current source? A source whose current is a function of voltage elsewhere in the circuit is said to be a voltage dependent current source or voltage controlled current source. Similarly, a source whose current is a function of current elsewhere in the circuit is said to be a current controlled current source. Now I'll give you some questions and I want you to tell me what are these sources. Hope you are all ready for that. I'll give you some dependent sources and I'll ask you to tell me what are these sources. Now I'll just give you some questions. I'll just give you two. Now, if I tell you this as 3v3, 8i1. Now, what is the first one and what is the second one? What is this second one and what is this first one? First point is, are they? Yeah, very good. Very good, Koteshwar. It is VCVS, voltage controlled voltage source. Very good. Very good. It is voltage controlled voltage source. And this is current controlled current source. This is current control. It's not voltage controlled current source. Very good. First one. Yeah, we see voltage controlled voltage source is first one. And this is current controlled current source. Very good. Very good. Hope you are able to understand this. So till now what we have discussed is what are the types of sources, and in that we have discussed what are dependent sources, and independent sources we have discussed voltage controlled current source, voltage controlled voltage source, current controlled voltage source, current controlled current source. This was the one part, and the other was independent sources. Then we have discussed what are independent sources. In that we have discussed ideal and practical voltage source. Yeah, very good, Raviteja. Very good. It is voltage controlled voltage source and current controlled current source. Very good. Ideal and practical voltage source. That was first one. And then we have discussed ideal and practical current source. So these were the points that we have discussed. So in dependent sources, it is represented by a diamond shape. This you need to understand, and here it is represented either by a circle or by this. And the resistance of an ideal voltage source is 0, internal resistance, and the internal resistance of an ideal current source is infinite. These are the important points in this. In some of the examinations in your semester, Mostly sometimes you'll be asked about these dependent sources. What are dependent sources? And explain different types of, I'll write the question. What are dependent and independent sources? What are dependent and independent sources? Explain. So this is one question that is generally asked in your semester examinations. So hope you are able to understand this different types of sources. Now next we will move ahead with Kirchhoff laws. Now we'll move ahead with Kirchhoff laws. We are moving next to Kirchhoff laws. So this Kirchhoff laws, you have two Kirchhoff laws. One is KVL, the second one is KCL, which is Kirchhoff's voltage law. Some may pronounce it as Kirchhoff's voltage law, or it is Kirchhoff's current law. These are basically dependent on law of conservation of energy. Kirchhoff's voltage law is dependent on law of conservation of energy, and Kirchhoff's current law is dependent on law of, it is based on law of conservation of charge. These are the two important points. In some interviews you'll be asked about this. Kirchhoff's voltage law is based on, it is based on law of conservation of energy, that is energy can neither be created nor destroyed, but one form of energy can be converted to the other. Or it is Kirchhoff's current law is based on law of conservation of charge. So let us discuss Kirchhoff's voltage law and Kirchhoff's current law one by one. Now coming to Kirchhoff's voltage law. I'll just give you simple statements. Simple सा statements ले लेंगे यहाँ पे. Kirchhoff's voltage and current laws. You'll be very easily able to understand these statements. Now, what is Kirchhoff's voltage law is algebraic sum of all voltages in a closed path is equal to 0, or sum of voltages in a closed path is equal to 0, or you can define sum of voltage rise is equal to sum of voltage drop. Alright, so this is Kirchhoff law. Let us consider one circuit. Now if this is a given circuit which has some resistance, you have two resistors in this. Let us call this resistance as R1, this as R2. This is the supply voltage and this is the closed path in which there is a flow of current. Because there is a flow of current, there will always be a drop of voltage which is denoted by V1, and there will be a voltage drop across this resistance V2. Now this is the voltage rise, or algebraic sum of all the voltages in a closed path is equal to 0, or sum of voltage rise is equal to sum of voltage drop in a closed path. So you can write it as, now algebraic sum of all the voltages is the sum of all these three voltages, that is V, V1, V2 summation is equal to 0. We will consider, you can consider anyway, but generally what I will consider is whenever you are leaving or whenever, see, the current direction is in this direction, just consider the leaving, the current is leaving which terminal. So take that value, this is plus, so I'll consider this as plus. And in your looking at this, the current is leaving the negative terminal, so this is a minus, which represents a drop in voltage. And similarly current is moving in this direction, so this is a drop in voltage. So this is the algebraic sum of all the voltages is equal to 0, or else you can write it as sum of voltage rise is equal to sum of voltage drop. V is equal to V1 plus V2. So this is Kirchhoff's voltage law. So let me give you a simple example. Now if you have a circuit like this, if you have a circuit, simple circuit, let us say this is the simple circuit that you have, and if I say, I'll not give you the resistor values, but I say this is 10 volts, this is 7 volts, let us call this as V. Now when I ask you find V without knowing any values of R1 R2, you can directly tell V is equal to, what is the value of V? I want you guys to tell me what is the value of this V. Some students will ask, sir, R1, R2 values are not given. How to find V? You need not know the values of R1, R2 in this particular circuit if a question is given like this. What is the sum of the voltages in this? It is, one is 10, the other voltage is 7, the other voltage is V is equal to 0. Simply you can say 10 is a voltage rise, minus 7 is a voltage drop, minus V, because these are voltage drops, right? So that is the reason we are representing them voltage rise, and these are voltage drops. So voltage rise is from minus to plus, or it is current is leaving the plus terminal. Voltage drop is from plus to minus, current is leaving the negative terminal. So this is equal to 0. So it is 10 minus 7 minus V equal to 0, or V is equal to 10 minus 7, or V is equal to 3 volts. Writing units is very important. You should write the units. This is mandatory in circuit theory. So this voltage V is equal to 3 volts, or by inspection you can say if this is 10 volts, this is 7 volts, this is directly 3 volts. This is the essence of Kirchhoff's voltage law. Hope you are able to understand this. Now let us look at Kirchhoff's current law. We will also solve many problems in my special classes on Unacademy. Please do join there, and you will come across a lot of problems that I will be solving, which are very much important for your semester exams also. The one thing that you need to observe is, this is one part that you need to understand, which is when you are defining a Kirchhoff's voltage law, you should say that it is based on law of conservation of energy, and also the closed path. In a closed path, algebraic sum of all the voltages is equal to 0, or sum of the voltage rise is equal to sum of the voltage drops. And Kirchhoff's current law, it is based on, I have already told you, it is based on law of conservation of charge, and it states that at a node or a junction, we'll also define this node, junction and all in graph theory as well. At a node, algebraic sum of all currents is equal to 0. This is one definition, that is sum of total currents is equal to 0, or you can also state it as at a node, sum of entering currents is equal to sum of leaving currents, or sum of I entering is equal to sum of I leaving, or in some other books it is also written as at a node sum of incoming currents to that node is equal to sum of outgoing currents, that is sum of currents incoming is equal to sum of currents outgoing. This is how it is written as. This is how it is written as. Let me explain you this. Now consider a node. Let us consider a node, and let us say there are n number of branches that are coming out of this. There are n number of branches that are connected to this, to be specific. And if I say there is some current I1 that is entering, I2 that is entering, I3 that is entering, and let us say I4 that is leaving, and this is a node, let us call this as node 1. So we can say that at node 1, if you apply Kirchhoff's current law, what does it state? Sum of entering currents is equal to sum of leaving currents, or sum of currents incoming is equal to sum of currents outgoing, or algebraic sum of all the currents is equal to 0. Now I'll tell you one by one. If you say sum of entering currents is equal to sum of leaving currents, what are the currents entering this? I1 is entering, I1 is entering the node, sum of entering currents where node. I1 is entering, I2 is entering, I3 is as well entering. If you see I1 is entering, I2 is towards node, I3 is also towards node. And what are the leaving currents? I4. Similarly, you can also write sum of currents incoming is equal to sum of currents outgoing. What are the incoming currents? Entering is nothing but incoming. So I1 plus I2 plus I3 is equal to I4. Now whenever you write algebraic sum of all the currents is equal to 0, you must be very careful. First you need to write all the currents I1, I2, I3, I4 whose algebraic sum is equal to 0. If you consider entering currents as positive, you need to consider the leaving currents as negative. So if I consider entering as positive and the leaving must be negative, this is the meaning of algebraic sum of all the currents at a node is equal to 0. So hope you are able to understand this. Let me give you one problem so that you will feel it very easy to understand. Now if this is a given circuit and there is some resistance value, this is the other resistor, this is R2, let us call this as now if this value is 7 amperes, this is 2 amperes, what is the value of this I1? Now if I give you a question, find I1, I want you guys to tell me what is the value of I1. Karthik Jilla, good evening. Good evening, Karthik. By applying KCL, you can simply tell the values of I1 even if you do not know the values of R1 and R2. So by KCL, you can say that at this node, because this is the same node, you do not have any element here. If this is node 1, this is node 1, because the voltage at these points is the same. So sum of entering currents is equal to sum of leaving currents. What are the entering currents? 7 is the only current that is entering. What are the two currents that are leaving? 2 and I1. You can write I1 is equal to 7 minus 2 is equal to 5 amperes. Therefore, what is the value of I1? It is 5 amperes, or by inspection you can directly tell 7 is incoming, 2 is outgoing, so the rest is 5 which has to flow through this R2. Yeah, 7 minus 2, 5. Very good. Very good, Kundan. It is 7 minus 2, 5 amperes. That's very true. So these are very simple examples of Kirchhoff's voltage and current laws. Hope you are able to understand this Kirchhoff's voltage and current law. Now let me also tell you what is called as current division and voltage division rules. Shalini, good evening sir. Very clear explanation. Thank you Shalini. Thank you for joining circuit theory. Now let me tell you what is voltage division and current division rules. Voltage division rule and the other one is current division rule. Voltage division rule and current division rule. Good evening Shravan sir. Good evening SVS online education training. Good evening. So let me tell you what are voltage and current division rules. Now if you say you have a circuit, let us consider one circuit and there are two resistors and this is resistance R1 and this is R2, and if you have a voltage, we already know in a closed path there will be a flow of current, and if the voltage drop across R1 is V1 and if the voltage drop across R2 is V2, by KVL we know how to find the values of V1 V2. But instead you can also directly find, let us consider one example so that you will understand very easily. Let us say you have a circuit like this. I'll discuss this current source a little later. Let us consider this same circuit with some values. If this is 5 ohm and this is 3 ohm and this is 8 volts, and if you are asked to find what is the voltage across this V1, voltage across this, the question is find V1 is equal to. How do we find? By using Kirchhoff laws. First we'll apply Ohm's law. So we can write 8 is equal to 5 into, if this is the current I, 5I plus 3 into I. So you can write, sorry. So you can write 8 is equal to 8 into I, or I is equal to 8 by 8 as 1 ampere. Then you can find what is V1. V1 is the, what is V1? V1 is the voltage across the resistor, 3 ohm resistor. What is the current flowing through this 3 ohm resistor? The same current I. Therefore, what would be V1 is equal to? Therefore, V1 is equal to 3 into I. So, 3 into 1 ampere will give you 3 volts. This is how you will generally find the voltage across one element, which is if there are n number of elements in series. Darawat Sidhu. Good evening Sidhu. Welcome to Circuit Theory Crash Course. This is the procedure that you generally follow, but you can directly get this value by using current division rule. Let me explain you that. Hope this is clear for you. I'm just deleting this and give you other method. Current division rule. What does current division rule state is voltage across, I'll just write it down better. Voltage across any element which is in series, to be specific in a series circuit, is equal to the total applied voltage into same branch resistance by the total resistance. So that is, if I want voltage V1, what is the voltage across one element? V1. Let us call voltage across this as V2. Voltage across any element is equal to total voltage. What is the total voltage? 8 into same branch resistance is 3 by the total resistance is 5 plus 3. Total resistance is summation of these two. So this is 8 into 3 by 8, which is V1 is equal to 3 volts, which is same as the voltage that we have obtained. Take minimum 30 to 40 hours and explain whole subject like this. It's very useful. Thank you. The definitely will try, because this being a crash course, hope taking 30 to 40 hours will not be possible, but definitely I'll try to explain you clearly. Uh, we'll have special classes on Unacademy app, so you can join me there on Unacademy. We'll have special classes. We'll have a detailed discussion of control systems as well as the circuit theory. And thank you. So this is the voltage. This is the way in very few steps you will be able to find voltage across any elements by using this voltage division rule. Now let us see how do you get that voltage division rule. Voltage division rule. Now let us write in terms of formulae. Now let us consider the same circuit that we have considered just now. Thank you, sir. Thank you, Koteshwar. This is R1, this is R2. Let us take this current as I, this as V2, and this as voltage across R1 as V1. I'm sorry. Yeah, this as V1 and this as V2 voltage. Let us consider this is the voltage, total voltage. Now, if you have to derive what is the voltage V1 expression and V2 expression, first we need to write what is V is equal to I into R1 plus I into R2. So, from this you can write V is equal to I into R1 plus R2, and you can write I is equal to V divided by R1 plus R2. This is one expression of current. Now, what is voltage V2 or V1? Let us consider the voltage V1. V1 is the voltage across resistor R1. So, what is V1 is equal to? The current flowing through this is I. So, I into R1. So, we can write V1 is equal to I into R1. What is I already? V into V by R1 plus R2 into R1. So, V1 is equal to V. So you can write V is equal to V1 is equal to V into R1 by R1 plus R2. Now if you observe this equation that I have told you directly in the previous slide, it is the V1. V1 is the, what is V1? V1 is the voltage across any element is equal to total voltage or the applied voltage into what is R1? R1 is the resistance of V1, right? V1 is the voltage across R1. So V1 is the voltage across any element is equal to applied voltage into same branch resistance. Wherever you are finding V1, that branch resistance by the total resistance. That is what I have written in the previous slide. Voltage across any element is equal to total applied voltage into same branch resistance by the total resistance. So this is the explanation or the expression that you get, which I have told you directly in this case. So this is voltage division rule. Now let us discuss what is current division rule. Similarly, you also have current division rule. Although I'll not derive it, I'll just tell you current division rule, what is the importance of it and why we are using it. Let us say you have a circuit like this. I'm taking a current source directly. You can either take a voltage source, and this is a two resistors parallel circuit. We'll discuss how the resistor series and parallel and how to find the equivalent resistance also. Now if you have something like this is I1 and this is I2. The current division rule states that it is useful to determine the current in any parallel branch. So directly, so current in any parallel branch is equal to total current into opposite branch resistance by the total resistance, which is the summation. Now let us say, so once again I'll repeat. Sir, please explain importance of polarity notations and how to take them. Definitely, I'll also tell them. Current in any parallel branch is equal to total current into opposite branch resistance by the total resistance. Current in any parallel branch is equal to total current into opposite branch resistance by the total resistance. Now what is, let us say we are asked to find current in R1. So I can write it as I1 is equal to, what is the total current? I into opposite branch resistance. We are finding I, which is the current flowing in R1. So we need to take the resistance of the other branch, which is R2, unlike the voltage division rule, by the total resistance, which is the summation of these two resistors, R1 plus R2. Similarly, the total current I2, or the current in any parallel branch I2, is equal to total current, that is the applied current, into, we are finding current in I2. So the opposite branch will be R1 branch. So R1 by R1 plus R2. So this is how you will determine current division and voltage division rules, and you can also find the currents in parallel branches using this current division rule. Let me take you one example and tell you clearly how do you get that by a simple example. I'll take a current source. While deriving, you can take a voltage source. For a problem, I'm just taking this current source example. Let us say you have two resistors. Let me call this as 10 ohms. This as 6 ohms, and this as 32 amperes. Now if you observe, if you are asked to find what is the current I1 and I2, so current in any parallel branch I1 is equal to total current 32 into opposite branch resistance 10 by the total resistance 10 plus 6 will give you 32 into 10 by 16. 16 2s are 32, so 20 amperes is the current of I1. Hope this is clear. Now if you want to find current I2, it is the total current into opposite branch resistance 6. When you are finding I2, the opposite branch is 6 ohms, right? So 6 by 10 plus 6. So it is 32 into 6 by 16 will give you 12 amperes. Now if you, according to KCL, you should also justify, if this is 32, what is I1? I1 is 20 amperes, I2 is 12 amperes. Now if you add these two, because these are the leaving currents, you should get this current that is being supplied. Now if you add these two, it is 32 amperes. So whatever the values that we have got for I1 and I2 are correct. You can also justify. You can also justify like this. You can also verify, if you can say. You can justify or you can verify your answer like this by applying KCL at this point. Some of the incoming currents is equal to some of the outgoing currents. If you check the answers that you have got and if you add them, you should get the supplied current. Now I'll just give you the one that is asked how to take the polarity. I'll just give you a small example and tell you. Now if, as you know, the battery terminals are given like this, I'll just tell you one example. Let us say you have a battery, mobile battery that you can take, which is being charged. Now if you take this is being charged. So I'll take this as, now when you are charging it, the current is flowing inside, right? Whenever you take, the current is flowing into your battery, that means you are charging it. The charges are flowing into your battery. And if you take the other case, when the charging is complete and you are using your mobile, it delivers. Now, if you observe these two cases, in this case, it is acting like a sink, which is taking the energy, or absorbing. In this case, it is acting like a source, which is delivering. The current is in this direction. Now, whenever you have a drop of voltage or a rise of voltage, whenever you have a rise of voltage, when you are taking rise as minus to plus, you can take the fall or drop of voltage as the current flowing from plus to minus. So this is called as rise of voltage and this is called as drop of voltage. Whenever you are delivering that, there is some drop of voltage inside it. When you are taking it as the sink, or when you are taking it as this, it is, there is a rise in the voltage. So you can take them as rise and drop of voltage. That is the reason you will take plus and minus. You can either follow this method or you can directly take whenever you have a plus and minus, and if you take current in this direction, let us say current is taken from negative to positive, it is a rise of voltage. And whenever you have, or you can take the same thing, and whenever you have the same thing, when you have this, and this is plus minus, and when you have the current direction, you can say it as drop of voltage. Either you take plus for this, then you take minus, and if you take minus for this, you can take plus. It depends upon the current direction taken, also depends upon you if you want to take it this as plus or this as minus. But in general, what we will consider in our course as the rise of voltage, if the current direction is in this direction from negative to positive, is taken as, or some others say it is positive negative, but I'll say it is negative to positive as plus. And when the current direction is in the reverse direction, I'll take it as minus. So you can call it as rise of voltage and you can call it as drop of voltage. Hope this is clear. Even in case of a resistance, because it being a element that drops, so you'll take it as plus minus in the direction of the current. If the direction of the current is in this direction, then you should take plus and minus in this way, because we are following it minus to plus as rise of voltage. So you should always consider from plus to minus as drop of voltage. Now some people, or some faculty, or some books will say that now if you are moving in this, if the current is taken in this, if it is plus to minus in this direction, it is a rise in voltage, and if it is in the opposite direction from minus to plus, it is a drop in voltage. Either you can take that, there is nothing wrong in that, but it depends on you who has to follow that. So you can take any of this. And thank you all, thank you for joining me today on this. I'll just tell you what are the takeaways from today's session quickly. First one we have discussed was about the sources, in which we have discussed dependent and independent sources, and also we have discussed what are Kirchhoff laws today, and I told you about current division rule as well as the voltage division rule. So these are the takeaways from today's session. So these are the topics that we have discussed today, and thank you all for joining me today. And excellent example, sir, and my doubt is clear. Thank you much for explaining very clearly. Thank you, Kundan, thank you for joining. And as I tell you, it's India's #1 study channels. We have GATE Creatrix Electrical, Unacademy GATE, Unacademy GATE CE, Unacademy Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Unacademy Foundation, Unacademy Pathshala, and also Unacademy Semester Exams. And please join us on Telegram, https://t.me/creatrixgate triple E. And please do like, share, and use my code YSK10 as referral code to get maximum discount. Please subscribe to our channel and click on this bell icon to get notification of my classes. And share karo sabko, like karo, and thank you all for joining me today. Please do join tomorrow with at same time 6:45 p.m. For a beautiful session tomorrow. Thank you all.